Hello everyone, welcome to the GATE lecture series of the S.A.E. Engineering College. Myself Dr.R.MADHANA in EEE department in S.A.E. Engineering College. So today we are just going to discuss about the three-phase transformer. So here I just mentioned the outlines of the three-phase transformer. This is only we are going to discuss in today classes. So like three-phase transformer, why we need to use the three-phase transformer and construction of the three-phase transformer and working of the three-phase transformer, following by that three-phase transformer types and constructions as well as the losses and calculations, followed by that rating of the transformer, finally the advantages, disadvantages and applications of the three-phase transformer, finally conclusions. So first, coming to the three-phase transformer, it is used for a step up or step down the voltages in various stages of the transmission system. And also in a three-phase transformer, it is made up of a three set of primary as well as the secondary windings. Each set of wound carrying the one leg of an iron core. So it is look like a three single phase transformer and sharing a joint core as shown in the figure. Then so why do we want three-phase transformer? What is the purpose of we need to use the three-phase transformer? So the in an electric grid we uses the three-phase transformer, three-phase power distribution for the distribution system. So it allows the higher transmission at a lower amperage. So this makes it is possible to use a higher gauge copper wire, and significantly it will also reduce the labor cost as well as the material cost. So that's why we need to use the three-phase transformer. So then what is the construction of the three-phase transformer? So the three-phase transformer, it can be constructed by the common magnetic core in both primary winding as well as the secondary windings. So in case of we are compared with the three-phase transformer with the single-phase transformer, here the construction can be a core type, either it is a shell type. So here in types of the construction of a three-phase transformer, the core type is shown in the figure. It is usually made up of three limbs in the same plane, and also it can be built using a stacked lamination. So each leg of this core carries a low leg voltage and high voltage windings. So the low voltage windings are insulated from the core than the high voltage windings. So then we will discuss about the shell type. In the shell type, it is three phases are more independent than they are in a core type, and also each phase has its individual magnetic circuits. And here we can see the shell type of a construction of the three-phase transformer. Then the working of a three-phase transformer is, it is a primary winding is connected to the phase AC supply, that means three-phase AC supply. So when the primary is excited to the three-phase supply source, three currents are started flowing through the individual phase winding, and also three currents produce the magnetic fluxes in the respective courses, so that in the three-phase system at any instant the sum of the all fluxes are in the same, and the fluxes induces the secondary EMF is in a respective phases such that they will maintain their phase angle between them. So this EMF drives the currents in the secondary and hence to the load as well. So it will depends upon the type of the connection we used in the number of turns in a coil, and each phase the voltage induced will be varied for the obtaining step up or step down the voltages. And what are the connections of the three-phase systems are available? In a primary winding and secondary winding, it's connected in many different ways. connections like star and delta to star, delta to delta, as well as the star to star. So here are some pictures are shown here. So coming to that, first we will discuss about the star to delta connection of a three-phase system. So in this, we particularly used for a star to delta connection is the purpose of to step down the voltages to a lower value, and also most of the industries and companies are using this connection to reduce the voltages for the level of the distribution system. And also the primary winding of the transformer is mainly connected with the star connected, and secondary winding is connected with the delta connections. Next we will discuss about the delta to star connections. This is the delta to star connection picture of the sample, and it is the main purpose of using is a step up the energy, that means voltage level, and it is commonly employed in a sending in or starting of a high tension of a transmission system. So in this connection we can able to see the delta connection is connected as a primary winding and star connection is connected as the secondary winding, so that the three phase of a 4-wire system at the secondary winding is possible. So next one is delta to delta connection. So this type of a connections are used whenever the supply source is delta connected and the secondary load is connected with the high voltage current. So this is generally employed for the three-phase power loads like a three-phase motor. For example, we are taking as the motor, three-phase motor, and in this both the primary and secondary windings are connected with the delta fashion. So next one is star to star connection. So in this connection both the primary windings are connected in the star connection. So also there exists no phase difference between the primary winding, that means primary voltages, as well as the secondary voltages. Then how we will calculate the power rating of the three-phase transformer? So when we are going to design a 250 volt amps step down three-phase transformer of a 440 volt to 74 volt, it is necessary to calculation along with the formulae are given in the coming up slides. So as we are going to design the small transformer, so we are neglecting the core and copper losses as they doesn't matters in a small transformers and seriously considered in a designing power transformers and as well as the high rating transformers. So how we will calculate the transformers? By the power ratings. Okay, so as we discussed in the previous slides, here the turn per volt is calculated the power ratings. So here the formula is given. For that I have given the an example. We are calculating the turns per volt using this area by the following. So putting, that means frequency is 50 hertz and B is magnetic flux density is 1.2 Weber and area is 0.01 2065. Then we will get, we already know that the formula is turn per volt is equal to 1 by 4.44 into F into B into A. So the turns per volts are 3.1 as we know that. So we have to substitute this. Then we will get the value. So this is the value for calculating the ratings. And this is the primary winding calculation and secondary winding calculations. So whenever we are calculating about the primary winding calculation, first number of turns in a primary winding is 3 into turns. So 3 into 220 is equal to 660 turns. So now we will find about the primary current. So the primary voltage is equal to Vp equal to 220 volt and primary current is equal to Ip is equal to PA divided by Vp, that means power rating divided by primary voltage. So as we know that the value we have to substitute here, then we will get the value for the current, that is nothing but 1.13 amps. Then the power rating will be denoted as PA and the secondary winding can be calculated as denoted as in primary winding. Here the number of turns in a secondary winding is 3 into 37, that is equal to 111 turns. So the secondary winding is equal to Vs. It is nothing but 37. So the secondary current can be have to calculate it. That is nothing but Is is equal to power rating divided by secondary voltage. That is nothing but 250 divided by 37 is equal to 6.75 amps. So next we will see about the losses in the transformer. In a three-phase transformer, we have the so many losses. In that, first we will discuss about the iron losses. In the iron losses, we will see it is caused by the alternating flux in the core of the transformer, and this occurs in the core. It is also known as the core loss. Iron loss is also called as the core loss. And next one is copper losses. So in a copper loss, it will occur because of the transformer winding resistance. And next one is hysteresis losses. Hysteresis losses can be occur because of the variation of the magnetization in the core of the transformer, and the eddy current losses can be occur in this losses of the transformer. So it will be when the flux link with the closed circuit, an EMF is induced in the core. Since the core is made up of conducting material, even though the EMF circulates currents within the body of the material, so it produces a loss in the magnetic circuit, so that it is also known as the eddy current losses. So then, what are the advantages of three-phase transformer? So, in a three-phase transformer, it has lots of advantages will be there. We will discuss about the few of them. So, in expensive, it is very compared to a single-phase transformer, the three-phase transformer comes to the cheaper price, and also it has a low cost when compared with the single-phase transformer. So, lightweight, that means not only in the transformer, lightweight is also smaller than the single phase transformer in a size, which means that it occupies the less space in the circuit, and it assembly in a least time. It is extremely easy to assemble compared to the single phase transformer. So higher efficiency. The three phase transformer performs very well, and also it functions more efficiently and delivers more power than the single phase transformer. So it is very easier to install when compared with the single phase transformer. So thus makes the installation process very easy and smooth. So what are the disadvantages of the three-phase transformer? So in a three-phase transformer, it has a disadvantages like a greater cost of standby units. It is nothing but the individual cost of the standby unit is high and makes it difficult to repair or fix and any malfunctions. And also cost of repair. The cost of the repair of a three-phase transformer is higher, since the changing each individual components are very expensive. So reduced capacity. Since the three-phase transformers are self-cooled, the capacity of the transformer is also reduced simultaneously. So fault correction, in case there is any fault in any phase, so it will affect the another two phases. So as a result, the whole circuit needs to replacement. Then the applications of the three-phase transformer. So it is mostly used for the purpose of step-up and step-down purpose, and it is for the purpose of level of voltage at the generation side before transmission and distribution. In a distribution side, the commercial or domestic purpose, it is going to be used for a electricity transformer for the level of the step-down to the level of the low voltages. And finally, coming to the conclusion, when we are compared with the single phase transformer, three phase transformer is having the more advantages, and also this is reason why we are going to for the three phase transformer. So now we will discuss about the previously asked questions in a triple E. So, which three-phase connection can be used in the transformer to introduce phase difference of a 30-degree between its output and corresponding input line voltages? So, as we discussed in the previous slides, we will come to know that star to star, star to delta, and delta to delta, delta to zigzag. So star to delta is the three-phase connection which can be used here. And next one is keeping in a view the requirement of the parallel operation, which of the three-phase connections giving the below are possible. So as I said in previous, delta to delta, delta to star, delta delta to star delta, star star to delta star, and delta star to star delta. So compared with all the connections, we will getting the delta star to star delta giving the better one, giving the possible connections. And let me solve one problem as we discussed in the three-phase transformer. Here a three-phase 900 kilovolt ampere 3 kV per 3 kV and 50 Hz transformer has a primary resistance per phase of the 0.3 ohm and secondary of the transformer is 10 kilowatt and the full load is efficiency of the transformer operated at unity, power factor is dash, and we have to calculate it. So the data is given here. How we will calculate this? So for that, first we need to know the formula. So for finding the full load efficiency, we have the formula. Eta is equal to output power divided by output power plus total losses into 100. So first we need to know the data. So step 1, we will discuss about we have to write the given data in the available questions. So transformer rating will be there, primary winding, secondary winding, primary resistance per phase and secondary resistance per phase, and iron losses, power factor and frequency. Step 2, what we have to do means we have to calculate the full load current. So primary side current, for that we need to find out the S is equal to, it is nothing but the apparent power. S is equal to 900 kVA. The kVA can be noted as the 900 into 10 to the power of 3 into VA all times. So since the primary side of the delta connected is can be calculated by using this formula. So by using this I1 we can calculate the current S by root 3 into V1. So we know the value of V1 as well as the apparent current. So we can apply it here. And secondary side of the current can be calculated by using the this formula. So phase voltage is formula can be V2 by root 3. So the secondary current is calculated by I2 is equal to S by root 3 into V2. So 900 into 10 to the power of 3 divided by root 3 into V2. Since this is a star connected and phase current is same as the line current. So step 3 we have to do copper losses. So copper losses is equal to I square R1 plus I square R2. Since the transformer is the three phase, so total copper losses is calculated by using the formula. So copper loss is equal to 3 into I square R plus I2 square R. Okay, so then by using the I1 we calculated here, so we have to substitute in the formula. So 3 into, we know the value of I1 and R1 plus I2 into R1, R2. So we have to supplying that we will get the value for the copper losses. So finally we need to calculate the total losses. So total power losses is equal to copper loss plus iron loss. So copper loss as we calculated we need to substitute, iron loss will be there in the our question. So we need to substitute that also. So finally we will get the total power losses is equal to 18.63. So finally we need to calculate the efficiency of the system. So the output power at full load is equal to, the P out is equal to S into power factor. So equal to 900 into 1. So 900 kilowatts. So efficiency is equal to, as I said in previous slide, output power divided by output power plus total losses into 100. That only we need to substitute here. So we know the values for all the values. So we need to substitute here. Then we will get finally efficiency of the value. So efficiency of the given problem is, we are getting that 98.02 percentage. So similarly we will solve the next problem based on the three-phase transformer. So here they are mentioned like two three-phase transformers are realized using the single-phase transformer as shown in the figure. The phase difference between voltages V1 and V2 we need to find out. So, based on this figure, first we are taking that, assuming that ABC phase sequence in a clockwise direction. So when we are connecting with the start, that means delta to delta connection, both the primary winding and secondary windings are in a same phase. That we can able to see in the from the diagram. And here when we are connecting with the delta to star connection, it will vary when secondary winding is leads by the what? Leads by the primary winding. So when we are connecting to the both primary winding and secondary winding connected with the two phase, that time we will get the difference between the 30-degree angle. So finally when we are connecting with the delta to star, it has the 30-degree of the phase difference, and when we are connecting to the delta to delta connections, we will get the same what? Same phase difference. There is no difference between that same phase. Okay. So finally this is the conclusion of that given problem. Thanking you. Let me discuss about the remaining class session. Continue in the next session. Thank you.